Hello everyone. Today we're going to talk about lab number 8, which is diode applications and rectifier circuits. As we know, a rectifier circuit is the basic building block to convert an AC signal that comes from the power outlets in the wall into a DC signal that, let's say, the device can use. So we'll start with a little bit of an introduction. So for a half-wave rectifier, we have it like this. That's my input signal. That comes from the outlet. Now, when we apply it to a half-wave rectifier, only positive half cycles will pass. If you guys remember, the diode will reject the negative half cycles. What will happen later if you apply a filter, and basically it's a capacitor, my, let's say, pulsating wave here, it will be converted to this waveform here. And we will see now how the output will look like at each stage. So basically you have to, let's say, construct the circuit here for a half-wave rectifier, and we want to track the input voltage and the output voltage and see that only positive half cycles will appear and negative half cycle will be rejected, of course, with respect to the input signal. And later, after we do this circuit, we're going to do the full wave rectifier, and similarly we will get all half cycles passing. However, the negative ones will become positive and the positive ones will remain positive, and the output will be this, let's say, ripple kind of waveform. So let's start by constructing the half wave rectifier. So we'll go to multisim, create a new circuit. And we know that our input is AC voltage. We need a diode, and I think diodes is this one, because this one is passive elements. Diode is a different component. So just diode, and there you go. And we know this again, load resistor to show our output. And that's it, the circuit is done. All right. And we never forget the ground. So we want to track the input voltage, and let me modify the input voltage to have, let's say, 10 volts and frequency of 10 hertz. Let's make it simple, easier to visualize. And for the resistor value, let's keep it at 1 kilo ohm. It doesn't matter. So let's put our voltage sensors. So that's my first voltage. And the other one will be at the output side. Also, never forget the references. I have some students sending emails regarding that, why the voltage doesn't show up, because you forgot to put the reference. Reference is a very important component to show an accurate voltage. Now, in this one, actually, when we run the simulation, we will not look at the values here. We're going to look at the waveform. So if you see here graph, it will show the waveform. And yeah, basically it's waiting for data. We did not start the simulation. So we'll go to schematic, run it for a while, then stop. And yeah, you can see that the values here doesn't make any sense. It's just fluctuating. Now, if you go to the grapher, okay, yeah, there you go. So the signal will not show up, say, immediately. You have to play with the x-axis and y-axis. And yeah, to play with the x-axis and y-axis, you have to go to the y-axis here, and you see the cursor, how it changed, say like this, and like this. Now, when you have the cursor like an up-down arrows, you can control the y-axis scale by scrolling up and scrolling down. So if you scroll up, the scale will become smaller. If you scroll down, the scale will become higher. Now, for the x-axis, easier. Anywhere in the graph, when you see the arrows pointing left and right, again, scroll up and down, and you can play with the axis. Now, let's see. You notice that there are two waveforms. One of them is green and one is blue. Actually, if you go back to the schematic, the green one was the input. The blue one is the output. So I'm expecting the green one to be the full AC signal, and the blue one will become the half-wave rectifier signal, only the positive half cycles. And that's what we see here. So the blue one is only positive half cycles, and the green one is the full signal. So the first one is my input, the green one, and the output is the blue one. Now let's notice one thing actually. There is a difference between the peak values between of the input and the output. So let's say in this one here, the output, we are looking at the y-axis at the volts. So it's almost 9.98. Now, right below it, the blue one is 9.2. If you notice, the difference is 0.7, which is the barrier potential of a diode. Actually, if you double click, let's see if it shows the value. I think it's not. Barrier potential, no. Yeah, it doesn't show that one, but by default is 0.7 for the diode. Yeah, there are no parameters to modify in the diode, so you don't have to worry about it. And that's it. That's for the half-wave rectifier. Okay, so our output signal is these positive half cycles. Now I want to see if I apply a filter, because one of the requirements here, you need to apply this capacitor, a filter, with a filter. And let's add a filter of 1 microfarad. So we'll go back to schematic, go to the passive components. All right, do some rotation. And you don't have to worry about modifying the sensor location because they are in parallel, so the output will be the same. Now, once you add this capacitor and run the simulation, stop, go back to the graph, and let's play with the timing waveform. Yeah, there's no much change here because the time constant, something we did not cover in the class, was very fast. So the capacitor will charge and discharge immediately. Let's play a little bit with the frequency, and I modified it here to be 100 hertz. 1 kilo ohm, 1 microfarad. So let's go to the frequency, 100 hertz. Let's run. Graph, and there you go. You see how the waveform now becomes, let's say, it's not immediate half cycles. And you need to try with different values of capacitor. Let's try with 1 e to the negative 4. Go back to the schematic, double click here. So 1 e negative 4. I'm not sure if this one will work. Let's run the simulation. Go back to the graph and see. Now I'm getting like a DC-like kind of signal, and this is what happens. Let's say that's the cause of the charging and discharging of the capacitor. Now see how the blue one was just positive half cycles. Now it's becoming more into a DC-like signal, and that's it. That's what you need for this experiment. You need to do this circuit. That's the first part. Then you add a capacitor. And in each case, you have to show me the waveform. And actually, I believe the requirements are clear. So you need to run the simulation, insert this, let's say, circuit schematic, and the waveform below in this space. And this part is also here with a capacitor, and you have to do the same with different values of capacitor. So in this one, I'm expecting about 4 to 5 graphs. So that's it for a half-wave rectifier. I believe it's an easy one, and it's not challenging to construct. Now let's go to see the full wave rectifier. We need 4 diodes in this one. So let me clear this graph here, delete everything. We need an AC signal. We need 4 diodes in this case. So that's 1, 2, 3, and a resistor, and the output stage. Let's do a rotation. Okay, now let's see how this device is constructed. If you look at the circuit here, my input voltage goes in between D3 and D1. Well, let's not worry about the terminology here. Basically, let's draw a line between these 2 diodes and a line between these 2 diodes. Now my input goes in between the first 2 diodes here. If you go back here, there you go, there's the input. And yeah, please be careful about the direction of the diodes. So by default, the system will go give us these, let's say, anode to cathode location in the diodes, and they actually match what we have here. But here we have rotations because, let's say, we have like we in the figures. In this software, you cannot do rotations. So you just have to be either vertical or horizontal. So that's for the input. It's going to be between these two diodes. Again, let's not worry about the terminology here. It's showing D3, D1, D2, D4, and we have a different order. Doesn't matter. Those are just labels. And the other, let's say, part of the input goes into between the other two diodes. So something like this. Notice we have to do, let's say, these diodes connected. So let's connect them here. Similarly here. Now let's see what's left. The output RL goes between this connection and the other connection. So here is my output. So one is connected to this side and the other one to this side. And let me move this one a little bit down so the circuit will look clear. Now what is left is the ground. The ground usually, well, it has to be connected to the load. Some people might put it near to the source, which is incorrect. The ground has to be connected to the load. So there you go, that's the ground. Now we have the circuit fully configured. So let's change the values here to 10 Hertz to have easier visualization. And yeah, for the voltage, we want to have 10. So we have the diodes. There is nothing to modify in the diodes. And let's keep the resistor at 1 kilo ohm. Now let me track my inputs. So the input is the green one. The output is the blue one. And I think you can modify the color, like here. Sorry. Yeah, there you go. So you can make it red. Okay, run the simulation. It's working fine. Stop, go to the grapher. Again, you have to play with the x-axis and y-axis. There you go. And notice here. Now my positive half cycles, they passed. Again, the green one is the input. The red one is the output. So the green one is the actual signal. And notice here that negative half cycles have become positive. And that's the full wave rectifier. The positive half cycles will pass, negative half cycles will become positive. One important point here, let's look at the peak voltages. So here the peak is almost 10, and here it's going to be 8.6. The reason we have two diodes, and the barrier potential for these two diodes will be 0.7 plus 0.7, that's going to be 1.4 volts. So that's the first part here. Let's add a capacitor. Do a rotation. Okay, now for a better visualization, let's make it 1e to the negative 4. Run. Stop, go to the grapher. And actually you can have both, let's say the circuit and the graph together, we have split. But we want to have, let's say, the full graph. It will be easier to visualize. And yeah, let's modify the x-axis. There we go. And somebody will, let's say, will notice like, where did this other positive half cycle? Remember, this is the output. You cannot actually see both of them together. So what actually the output of the resistor is something like this. But since the capacitor will be having this charging and discharging feature, you will only get to see this one. You will not see the positive half cycles. Now, if you compare it to the half-wave rectifier, the signal was going all the way down, then charge up, and so on. Go all the way down, charge, and so on. In this one here, we have better, let's say, DC kind of signal. Because if the half-wave rectifier, this portion here will not exist. It's just only gonna descend all the way to here and go up again. So in this one, again, you need to submit for two cases. So the first one without a capacitor, it's fine. You'll get an output. Now, when you have a capacitor, I want you to do the same with 1 microfarad and e to the -4, e to the -5 farads. And yeah, the setup is here for both circuits. Let me see the first one. Yeah, probably in this one, you just have to look at the graph. Just focus on the values on the graph. And that's it. The lab is simple. You just need to play with the values and get the most of it. So if you have any questions, again, go back to Telegram or email. Please send me, and I'll be more than happy to answer any inquiries or doubts.